Okay, today we are going to learn about the first type of problem in projection of plane, that is a normal type of problem. So what is this normal type of problem means? So we know that there are two angle of inclinations will be there for the planes, right? So it is angle of inclination to the HP and it is angle of inclination to the VP, because our projection of planes problem depends on the three concept, right? So in the initial, that is the first projection, there will be no inclination, and in the second position we have inclination either to the HP or to the VP, and in the third inclination we have inclination with respect to the both the reference planes, right? That is what the concept for solving the projection of planes. Now in this normal type of problem, what happens if the angle of inclination with respect to the HP and PP, if it is there with respect to edge or side, this is what important. If it is there with respect to the edge or side, then we call it is an normal type of problem. Say, so this is our triangular lamina, right? Triangular lamina. Just I'm showing the top view. Say this is our first position with respect to the HP plane. It is resting with the HP plane with respect to its side, because we are considering left hand side. So in the first position we don't have any kind of inclination. So in the second position, so this is the HP plane. If we have inclination to the HP, see this. So this is what the inclination which we are giving. So if it is there with respect to this HP, so this is what the inclination with respect to this base edge. Okay, so this is what the edge which is having inclination. Okay, so inclination with respect to the base edge, this is what the inclination to the HP, one inclination that is there with respect to the HP. And then in the third position, say this is already inclined to the HP. Say if it is been inclined to the VP like this, okay, this is what perpendicular. So if we are moving like this is what the inclination to the VP. So inclination to the HP and inclination to the VP, if it is there with respect to this base edge or the edge, we can say that this is one of the normal type of problem. Okay, so understood, normal type of problem means the angle of inclination will be there with respect to the edge or side. So we call that type of problem as normal type of problem. Okay. Now we are going to learn the concept for beta angle problems in plane surfaces. Okay. So how to identify a particular problem is beta angle or not. Okay. So you can see in this, if any one of the angle of inclination with respect to HP or VP, any one of the angle of inclination. So you can take either the inclination to the HP or VP. If it is there with, you can see these words are important: median for triangle, diagonal for square, perpendicular bisector for pentagon, and diagonal for circle, and diameter for circle. Okay, diameter for circle, if it is given, then it is called as beta angle problem. You can see in these diagrams, for a triangle, a line drawn from this corner point to the exactly middle of the this side, we calling that is a median. Okay, for triangular type of problem, he will be mentioning a word called median. Okay, similarly for a square problem, he'll be mentioning a word called diagonal. Okay, diagonal will be there connecting the corner 2 points, so he will be mentioning that. So that is indicating that it is in beta angle. Similarly for pentagon, we have perpendicular bisector. If this word is mentioned, means it is an beta angle. Similarly for hexagon, they will be mentioning a word called diagonal. Okay, if that particular word is defined, means it's an beta angle. Similarly for the circle, you can see this circle. So there will be diameter given. The angle of inclination will be given with respect to diameter, any one of the angle of inclination. Okay, either with respect to HP or with respect to the VP. So that's how we can identify it is an beta angle problem. So remember it, any one of the inclination either to the HP plane or to the VP plane, if it is mentioned with respect to median for triangle, diagonal for square, perpendicular bisector for pentagon, diagonal for hexagon, and diameter for circle given, then it is an beta angle problem. Today we are going to learn about a new type of problem, that is appears to be. Okay, so this problem will be similar to your beta angle problem, but in this problem we should not find out the beta angle. Okay, other than that, the problem will be of similar to the beta angle. You can see that in appear to be type of problems, you can find in the question the angle of inclination will be there with respect to like median for triangle, diagonal for square, or perpendicular bisector for pentagon, diagonal for hexagon, and diameter for circle. But in addition to these words, so there will be a particular word that will be mentioned in the question that we call as appears to be. If appears to be is given in the question, means the problem will become normal type, and in this type of problem we should not find out the beta angle. Okay, remember it in the question. In addition to these words like median, diagonal, perpendicular, bisector, diameter, they'll be mentioning a word called appears to be. If appears to be mentioned in the question, means the problem will become normal type and no need to find out the beta angle.